What? No, I gotta have something for you to work for. Okay, so today we are going to, you got your new sheet. It says on here, ideal gas law plus everyone's favorite subject, stoichiometry. Okay, so none of what I'm going to teach you today is at all new. This should be a review. It's just an application of two different principles combined into one.
That's so hard.
I know. Okay, so on this sheet, it's basically a flow chart. What your object is to figure out which one of the colored circles you start in, and then which of the colored circles you need to end in. All of the arrows that take you through the flow chart have instructions for what to do. But this is not new, and something that you should not, you really should not need this because you know how to do stoichiometry already, and you know how to use the ideal gas law. This is just putting these two concepts together. Okay, so I'm going to give you an example problem on the board. I'm going to make this up, so where are these numbers coming from? Right here. And we're going to use this example to help us navigate the flow chart. Okay, so we need, firstly, whenever you see a chemical reaction with these problems, that's how you know you're going to need this flow chart, because the chemical reaction is the dead giveaway. So let me give you a chemical reaction. Let's say that we are trying to make water vapor from these two gases. Is this reaction balanced?
No.
Sadly, no. Okay, so balance it. Okay, so here's your example. I want you to write down what I write on the board. I guess maybe you're going to have to put this in your notes.
You didn't try this on our tan sheet. You could do.
You don't have room on your tan sheet. If 6 liters of O2 is reacted at, I'm just going to write STP down. I will explain what that means momentarily. How many grams of water vapor can be produced? If 6.0 liters of oxygen is reacted, I guess are reacted, would be proper English, my bad. At STP, how many grams of water vapor can be produced? So my strategy for solving these problems is to write down information just like we did in regular stoichiometry underneath the chemical involved in that reaction. God bless you. So I have a number, 6.0 liters, and it tells me of oxygen. So that's why I'm writing it here underneath oxygen in my chemical reaction. Which of the variables is liters? Which of the letters? Mason?
V.
Correct. So I'm going to write V equals 6.0 liters. Now I wrote down that this is happening at STP, and I know that you don't know what that means. STP stands for standard temperature and pressure. You need to know this. I would maybe write this down someplace on my brown or my white sheets, or maybe both. So the standard temperature is 273 kelvins. and the standard pressure is 1 atm. We will never use these numbers to determine significant figures because they are constants. They are considered to be exact. In other words, we can't control the temperature or the pressure, so therefore we can't determine significance from them. But that does mean that I can write other information underneath my oxygen. And so I'm given a V, a T, and a P for one substance. Did you get a new water bottle, Joe?
No. Different one.
Oh.
Either one.
Okay, so let's look at our flow chart. We need to figure out firstly which of the colored circles we are starting in. So it's going to usually either be yellow or blue. Are you given a grams of your first substance?
No.
No, so that means we're starting in the blue circle. Okay, now what is our question mark? It tells me how many, or it says in my problem, how many grams of H2O. So that's question mark grams. This is substance B, and this is substance A.
What is PVT?
Pressure, volume, temperature. So it means that we're given pressure, volume, and temperature of substance A, which is true. We have pressure, volume, and temperature of substance A. And then we need to figure out the number of grams of substance B. So which of the colored circles will we end in?
Purplish.
The pink one. Yes, the pink one. Okay, so let's just do what our flow chart tells us to do then. So the first step is to figure out the number of moles of substance A. We will do that by using the ideal gas law.
Alright, slow down. Stop for a little bit. Michelle. What?
So we're starting here in the blue,
Oh.
and we need to get to pink. And so to get, to go through all of the processes, I need to go first to the green. And so my sheet will tell me that I should use N equals PV over RT. Does that make sense in how to use the flow chart? So if you just do what it tells you, you should be always good. So we know how to do this. P is 1 atm. V is the 6.0. What's my R value? Yes?
0.0821.
Correct. How do you know? If you don't have it memorized, just look at your brown sheet. It tells you what they all are. And then the T,
Wait, what is R though?
it's the ideal gas law constant. It has a fixed number, and it is determined by the unit of your pressure. Okay, so then this is just simple math. Now, it's simple though. If you press that divide key on your calculator, the very next thing you need to do is open up parentheses. Yes?
How do you determine A and B again?
B is the thing you don't know. B is the thing that has question mark.
Alright.
So 6 divided by 0.0821 times 273. I got 0.27. I believe you should have only 2 significant figures because of 6.9. What's your unit here?
Is it grams?
Nope. It is moles. Of what? Yeah, so now it's important that we write mole of O2. Because we've got more than one substance here in this problem. Okay, so right now we are in the green circle. But we don't want to end in the green circle, we want to end in the pink circle. So what does the next step say to do? It says that we need to use stoichiometry. So I'm going to take this number that I found in my previous step, and I need to use my balanced chemical equation. So again, on your flow chart, it says little b moles of big B divided by little a moles of big A. What's little b? Little b is the stoichiometric coefficient in front of big B. So in this case, little b is what's little a? 1. Okay, wonderness. You should get 0.54. What's your unit now? Of
H2O.
good. Now we're in the red circle. Well, we don't want to end in the red circle. We want to end in the pink circle. So now it says to multiply by the formula rate. 18.02 is your formula weight. And you should get 9.6. What's your unit now? Of?
B.
Correct. How was that? Mason.
I just want to ask because I rounded the 0.2676 whatever to 0.27 initially, which just didn't read it, so my answer was 9.7 instead of 9.6.
Yes.
That right?
Yes, that's fine. I recommend that you don't round until the bitter end. So I just choose to leave all of the numbers in my calculator. I might write 0.27 on my paper, but I will leave the original number in my calc until I'm done with all of the calculations. All right, how was that? That was okay?
Is that good?
All right, let's take a look at a homework problem now.
8.
All right, let's do number 8. I'm going to just quickly write the chemical equation. I want you to figure out if this is balanced or not.
Oh. Yeah, that's good.
I think it is.
I think it is too.
Where are we doing this one?
On your it's number 8 on your homework.
Where are we going?
You got it last time. It's homework number 6. Duco, are you okay?
Yeah, I'm just tired.
What are you doing with all this?
What?
Are you playing video games?
No, I woke up early this morning.
You're trying to give him a wet dream?
No.
Joseph, I'm recording.
No.
That's what you already said.
I'm doing a scientific experiment. Sorry.
I don't like dreams.
Hayden!
Out of the subject, apparently.
You're going to have to bleep it out now.
I'm not doing that. All right, number 8. When calcium carbonate is heated strongly, carbon dioxide gas is released. Oops, forgot a period. What volume of CO2 measured at STP is produced if 15.2 grams of CaCO3 is heated? Okay, so what is question mark?
B.
V of
CO2.
So I would write that underneath the CO2 in my chemical equation. That's what I would do. You have to indicate your data somehow. That's how I would do
Oh,
it.
we're going to be going to the purple one this time, huh?
Ooh, good eye. Good eye. So it does say that it's measured at STP. So what is my T?
273. Okay.
Thank you. And your P is?
180.
Good. And then where does that 15.2 go? Nope.
CACO.
A double up.
It is. So you've got 15.2 grams of this. Okay, so which colored circle are we starting with?
Yellow.
Yellow.
We are starting with yellow. And what color circle are we ending with, Joe?
Purple.
Purple. So we got to do yellow to purple. At the beginning it says to convert to moles and we divide by the formula weight. So, I don't know how you want to write this. You've got to show your work some way. This is how I do it. This isn't the way you I guess
I just do 15.2 grams divided by.
you can, but you can actually do 2 steps in one if you do it this way.
What do you mean? Can't
I'll show you.
Fucking divide it right
Well, what's the 15?
The 15.2 is what you started with.
there. 2 steps in most too much for me, I think.
Alright, so your formula weight, ladies, you have to stop talking. Your formula weight is
Stop.
A lot.
Stop.
Did not do anything.
109.
Ow, right. Stop.
gentlemen. Joseph, move your chair this way.
He hit me.
More.
Why am I
Okay, so I guess I will not show you both steps in one, but you could just keep going. Okay, so 15.2 divided by 100.09 is
A lot.
a little. I need 3 significant figures. Why? 15.2. What's my unit here?
Moles, CO2, or CO2, sorry.
Now we are in the green circle, but we need to end in the purple. So the next thing to
use
do
stoichiometry?
is to use stoichiometry. So if you knew that, you could just continue on with this next step here without having to do a third, like writing this again, but that's okay. So since we decided that this chemical equation was balanced, your ratio is 1 to 1. What substance goes on the top of this fraction though? CO2. Because that's what substance B is. B is the person who has the question mark underneath his formula in the equation. Okay, so you should get the same exact number because a number divided by 1 is 1. But now what's your unit though?
CO2.
If you don't show this step, I'm going to mark it wrong even though your number is correct. Because if you don't do it every time, you will get the ones incorrect that aren't a 1-to-1 ratio.
Tan sheet.
So if you don't, so in other words, if you don't show this work here in the green circle, I'm not going to give you points for it. Okay, so now you're in the red circle, but now to get to the purple circle, what does it tell you?
Tan sheet formula.
Use your tan sheet formula. Okay, so the reason it says use your tan sheet is because for every problem, you might be looking for a different one of these 3 variables. So you have to decide which of the permutations of the ideal gas law you are going to use to solve for question mark. So if V equals question mark, you'll use nRT divided by P, right?
Yep.
Okay, so then what's your value for N?
0.1.
So what you just calculated. What's your value for R?
0.08.
Again, I found that by looking on my tan sheet, and I know that my pressure unit is ATM, and so that's what determines which of the R's you choose. T is 273. And so you get 3.404. What's your unit?
Liters.
How did you know?
You know, fucking guess.
Language.
Wait, don't we only need 3?
You do only need 3. It's liters because anytime you calculate a volume from the ideal gas law, it has to be in liters. So if you did not write that a little note to yourself on your tan sheet, consider doing that. Your unit for volume is always liters. So this is your answer. Questions? How did it go?
Were you supposed to do this on page?
Eventually, it's due. When is it due? Can somebody look on the front? When is it due? Monday? Okay, so you can have the rest of the time as your own. These do take some time to do. Next class will be a work day. So you'll have the entire time as well to work on this. And then also I'm working on a lab for you. You'll have to prepare that as well. So there'll be some things that need doing next time as well.